Hello, hi everyone. Welcome back to our Smart Interest YouTube channel. I'm 𝗏𝗏𝗃𝗲𝗃𝗃, and in this video, we are going to discuss the problem the undisappearance, which is of Codechef Starters 148 contest problem. So let's get started. So the problem statement says that you are given an array A of length n containing only integers 1, 2, and 3. Okay, and also it is guaranteeing that each of 1, 2, and 3 appear at least once in the array. Okay, so consider the following operations only. These are the following operations. The first operation is uh, okay, choose two integers L and R such that it ranges from 1 to n. Okay, and then each index from L to R, if that element at I is 1, then convert it to 2. Then if it is 2, convert it to 3. If it is 3, convert it to 1. That is, you will choose some non-empty subarray of A and add 1 to all its elements, except if it is 3, turn it to 1. Okay. And also here we have given an example to understand the above operation. So let's look at it. The array is 3, 1, 1, 2, 3, and 2. Okay. So they picked 3 to 6. Here they are assuming that it is 1 based indexing. So 1, 2, 3, 4, 5, and 6. Here they considered range from 3 to 6. If we consider this, here it is 1. So it turns into 3. Sorry, my bad, 2. Then this 2 converts into 3. This 3 converts to 1. This 2 converts to 3. So now the subarray changes to, sorry, the entire array changes to 3, 1, 2, 3, 1, and 3. So it is this exact same 3, 1, 2, 3, 1, 3. Okay, I hope the question is clear. You will pick a range which is L to R. For each index in this range from L to R, you'll simply change the value from 1 to 2. If it is 2, change it to 3. If it is 3, change it to 1. Okay. And if you look at the last statement, we need to figure out how many ways can we perform this operation exactly once, such that the final array still contains at least one occurrence of each of 1, 2, and 3. Okay. So they're asking us how many ways, the number of ways to perform this operation exactly once. But still the array has at least one, occurrence of 1, one occurrence of 2, one occurrence of 3 at least. So such that we need to find those many number of ways. Right. So the, if you see the brute force solution that will come into your mind is explore every subarray. There will be n square subarrays. So if you iterate on each subarray and convert it to convert 1 to 2, 2 to 3, and 3 to 1, it will again take n time. So brute force is n cube according to the given constraints. The n can go from 3 to 10 power 5. Of course, this solution definitely gonna give you TLE, right? So somehow we need to optimize this. How can you optimize this? If you see the subarrays which has 1, 2, and 3, the number of subarrays which has one, at least one occurrence of 1, 2, and 3 will be more, right? If you talk about this intuitively, the number of subarrays which has at least 1, 2, and 3 after performing this operation will be more. So let me give you these terms. One is the valid subarrays are subarrays. Valid subarray, let's say ranging from L to R, if it is valid, That means it has at least one occurrence of 1, 2, and 3. If it is invalid subarray means either of these three value, out of these three at least one is missing, right? uh, Out of 1, 2, and 3, if even no occurrence of any of these three values, that comes under invalid subarray. Okay, so intuitively the valid subarrays will be more, right, than invalid. So let's do reverse engineering. Let's try to count invalid subarrays. So if we count invalid subarrays, how do we get valid subarrays? Because question is asking for valid subarrays, right? Count for valid subarrays. Simple, right? Total number of subarrays minus invalid, which will give you valid number of subarrays. So here we are trying to count invalid subarrays. Okay. So let's see how we can count invalid subarrays. Uh, Let me erase this. Let's take another example. Uh, let's say if you have an array of values, something like this, 3, 2, 2, 1, 1, 2, 1, say 2, 2. Let's say this is the array. Now, how do you pick the invalid subarray? How do we count the invalid subarrays? Let's try to count in this way. Let's try to remove just one. Let's try to remove all the ones from the subarray. Okay. So how can we do that? I'll pick the subarray which has all the ones. In the entire array, I'll pick a subarray which has all the ones. Right. So how do I get the subarray which has all the ones? Can you observe how do I get the subarrays which has all the ones? I mean, like it can have other values as well. My question is, how do I get the subarray which has ones and the remaining element should not be any one? This is the first index, first occurrence of 1, and this is the last occurrence of 1. This is first occurrence index, and this is the last occurrence index. If you flip this subarray, this gonna be 3, this gonna be 3. My bad. This gonna be this gonna be 2, this gonna be 2, this gonna be 3, this gonna be 2. So if you flip this subarray, there are no ones in this, right? So that means this is invalid subarray from here to here. So we got one invalid subarray which has no ones in it, right, after flipping it. So is it just this subarray, or can we expand this? We can expand this, right? So if you see, Uh, Let me move this to the down. If you see, as this is invalid, won't this also be invalid? What about this? Coming to this again, this becomes valid because as we have a 3, this gets flipped to 1. So we'll have the 1. So this cannot be considered. This cannot be considered. So there are three invalid subarrays. So instead of 1, we have 3. Is it just 3? No, right? So we can also, as we have expanded to the left side, we can also expand to right side as well until we don't have any 3 in the subarray. Until we don't have any 3 in the subarray. Till that point we can expand. As you can see here, we had a 3, so we cannot expand because if we include this 3 will convert to 1. So we'll get 1 in the subarray, which makes it as valid, right? So until we don't have 3 in the subarray, we can expand as long as we can. But we can only expand when this base subarray is invalid. This base subarray is invalid. How this is invalid? How this can be invalid? The same thing. When this subarray means the starting index, the first occurrence of the index of 1 and last occurrence of index 1, if it doesn't have any 3, that means it becomes invalid. Because if we don't have any 3, we cannot get 1 when we are flipping. So this becomes invalid. As we have seen for 1, this is for 1. The same thing will also apply for 2 and 3 as well. We'll look for first occurrence index of 2 and last occurrence index of 2, and then in that uh, in that subarray what value it should not have such that it becomes invalid. In 1 it should not have 3, right? Likewise, can you tell me for 2 and 3? For 2 it should not have any 1. For 3 it should not have any 2. As long as that subarray do not have 2, we can expand the subarray, and same thing for here as well. As long as it doesn't have 1, we can expand that subarray. And if you see here also, we can expand 2 more values. What will be the overall count? Here we can expand 2 values. Here we can expand 2 values. So what will be the count of total number of invalid subarrays? This is 1. We have 2 on the left side and we have 2 on the right side. So we can pick this and match it with these 2. So it becomes 2, and I can pick this and match it with these 2. So it is 2 into 2, right? Which is uh, let's say this as uh, 𝗟𝗃 and this as 𝗟𝗃. So it is simply 𝗟𝗃 into 𝗟𝗃. These are the number of invalid subarrays, right? I hope this explanation is clear. Let's jump into code. And okay, I have just moved this. If it is for 1, we'll try to check if it is by removing 1, if it is becoming invalid or not. So from the first occurrence index of 1 to last occurrence index of 1. There should not be. If there is no 3, that means it is invalid. If it is invalid, this subarray becomes invalid, and also we can expand it to left side and we can expand it to right side as well, right? So then if it is invalid, then we'll expand to left side, and we'll try to expand it to right side as long as the subarray does not have do not have 3. Same thing applies for 2 as well. If you are doing it for 2, you will iterate from first occurrence index of 2 and last occurrence index of 2, and there should not be, instead of 3 for 2, there should not be any 1. And here same thing, here there should not be any 1. For 3, you'll iterate from first occurrence index of 3 and last occurrence index of 3, and instead of uh, for 3 there should not be any 2, because only 2 can convert it to 3 while we are flipping. And same thing here as well, there should not be any 2 while expanding. This is expansion. This you can consider a third step. First, we'll check whether that subarray from first occurrence of that value to last occurrence of that value, if that subarray is becoming invalid, then we'll try to expand and find more invalid subarrays. Then at the end, we'll get the number of invalid subarrays. Then to get the valid, we'll simply subtract this from the total number of subarrays, which are n square, or to be precise, it is n into n plus 1 by 2. Subtract from this, you'll get the valid number of subarrays. Yeah, I hope you understood this completely. This is the entire summary of this. This is what we are going to implement now. First of all, we'll get the first and last occurrence. Before that, we'll we'll read the input. Let's jump into the code. Uh, yeah. So we'll start from scanner class stem.in and read the number of test cases. Then you'll be given the size for each test case followed by array elements. We'll read the array elements. We are done with the input. Now, first thing is to get the first index, first occurrence index and last occurrence index of 1, 2, and 3. To store this, let's have an array of array itself. Let's have 2D array of size. I'll just map it with the number itself of size 2. I'll again iterate on this array. And now for that element, I'll just this index represents the value, as we only have 1, 2, and 3. So at this index, to fill the first occurrence, to know that this is the first occurrence, I'll first fill this matrix with minus ones. Here I am not using index 0, right? Row comma minus 1. So I hope this is clear. This occurrence is storing something like this. Uh, for first index, we are just leaving it. For index 1 of this represent first occurrence index of 1 and last occurrence index of 1, and same thing follows for 2 and same things for 3. Right? So this is what I'm storing in this occurrence matrix. Okay. So am I iterating on the array for each value? I'll as I have filled this as -1. So when I'm filling it for the first time, I'll know that if this is -1, then this is the first time I'm seeing that value. If it is -1, I'll then put the index over there. Which is I. Last occurrence, not required to check any condition. You can directly fill that value with I. Okay, so with this, I'll get the first occurrence index and last occurrence of 1, 2, and 3. Okay, so this completes our step 1. And the step 2 is we have to do for 1, 2, and 3. That is check the invalid, iterate from first index and last index of 1, 2, and 3 and check if it is invalid or not. Right? So first let's look at one. Let's check for invalid subarrays by removing 1. To make it as invalid, there should not be any 3 in that subarray from this first occurrence, which is occurrence of 1 and 0 will give you the first occurrence index of 1, and then we have to iterate till, as these are index, we should put it as less than or equal to and 1. This will give you the last occurrence index. Till this range, if there is no 3 array of I, if at some point if there is a 3, that means this is valid subarray. So to keep track of it, I'll have a boolean value invalid 1 false, and I'll also have invalid 2 invalid 3 false. Here I'll make invalid 1 as true and break. Only if it is here, if it is true, that means we cannot expand it further. So here I'm trying to expand left and right. Okay, once this is invalid subarray, then I'll try to expand towards left and right. As we have seen here, we can expand it and we can include more number of invalid subarrays, right? Okay, so expand, let's have a variable which will keep track of right and for left as well. So from where we need to iterate? We need to iterate from this point, which is previous value of the first occurrence index of 1. So let's the first occurrence index will get from here. The previous of it will be this. As we are moving towards left, we need to decrement it. So same condition, as long as we don't find 3, As soon as we find 3, we'll break from there. And if it is not, we'll increment left count. Same thing we'll do for right as well. We'll start the right index from the last occurrence, the next value of it, I less than n. Now we are moving to right side, we'll increment. As soon as I find 3, I'll break. And then if it is not, I'll try to increment this value at the end to keep track of this invalid, as the number of elements can be 10 power 5. So the number of sub arrays can be more. So let's go with long initialize to 0. Let me name it count subarrays equals to 0, and here the invalid subarrays becomes left into right. And here we need to convert one of the type to long because at some point it might overflow the integer range, right? uh, yeah, we are just done with 1. Now we need to do the same thing for 2 as well. 2 again will iterate from the first occurrence of it, which is occurrence of 2, from 0 to occurrence of 2, last occurrence I plus plus. For 2 there should not be any 1. If at any point of time if we have a 1, then invalid of 2 will make it as true and will simply break. If the invalid of 2, if it is still the same, because we have initialized with false, if it is still false, that means this is invalid, the subarray is invalid. We'll try to expand towards left and right. So left equals to 1 and right equals to 1. We'll try to expand from occurrence of 2, 0, minus 1, and I minus minus. At any point of time, if we have a 1, we'll break from there, or else we'll increment left value. The same thing for right as well, but we'll start from occurrence of the last occurrence, the next value of it, plus 1, I is less than n, I plus plus. Now if the same thing, if at any point of time we find 1, we'll break from there, or else we'll simply count into the, we'll increment the r, and invalid subarrays becomes long of r, right? This is for 2, and same thing we have to do for 3 as well. That is iterate from the first occurrence, which is 3 to 0. I is less than or equal to occurrence of 3 to 1, I plus plus. And here we should not have any, 2, because 2, when we flip, 2 will become 3, so that becomes valid. Invalid of 3 will be true and will break from there. If not of invalid 3, then we'll try to expand towards left and right, and we'll iterate from uh, the first occurrence, which is 3 of 0, minus 1, and I greater than or equal to 0, I minus minus. If array of I, if it is not equal to, sorry, we should not any have 2. If it is 2, then we'll break, or else we'll increment left count. Same thing we'll do for, we'll expand for right as well, starting from 3, 2, 1, the last occurrence, the next value of it, I plus plus, and if array of I, if it is equal to 2, then we'll simply break from there and increment right. And the invalid subarrays will be increased by left into right. At the end, to get the total count, simply do total subarrays. We have to compute the total subarrays. We'll do that first, which should be of type long because there will be more number of subarrays because n can be 10 power 5 of n into n plus 1 by 2. We have to convert one of the value to long because it might overflow the integer range. Yeah, it is a long code. Let's see if there are any typos or anything. It's fine. Occurrence of 0. If it is 1 minus 1, we are putting okay. Invalid. Okay. And I'm starting from first occurrence and going till last occurrence. I should not see 3. I'll break and expand left and right. Here it should be 1. The last, we should start from last occurrence. Okay. For 2, I'm starting from first occurrence and going till last occurrence of it. I should not find any 1 in between. Okay. Left and right. Okay. This is for 3. By removing 3, same thing changes. First occurrence and going till last occurrence. We should not have any 2 here. Previous value of the first occurrence and next value of last occurrence. 0 and 1. Yeah, let's try to run it. Okay, we made a minor mistake. 50. One 21 and 11. Yeah, let's submit it. Yeah, got accepted. In the contest, if you could not solve, don't worry, don't get demotivated because this is problem with rating 2300. But make sure you upsolve it. Yeah, I hope you've understood the problem completely. That's it for this video. If you want to learn problem solving in detail, you can join our 3-month Smart Coder course and master data structures and algorithms. We hope you liked it. To enjoy more such content, like and subscribe to our channel, and bye guys.